All right, so this video is going to go over state space models. So, state space models, which are also known as state variable models, can be linear or nonlinear, time varying or time independent or time invariant. But the big requirement for them is that everything has to be in terms of first order differential equations. So, if we have an example where we have md double dot plus c d dot plus kd is equal to f, for a mass spring damper system with a force acting on it, that's not in the right form because we have that d double dot there. If we have something like d dot is equal to v and mv dot is equal to f minus k times d minus c times d dot, well, we're getting closer, but still not in the right form because we don't want to have one equation with two dots in it. We don't want to have that d dot there on the right side when we also have v dot also on that right side. So an example that's getting really close, if we have d dot is equal to v, and then mv dot is equal to f minus k times d minus c times v, that's almost the right form. All we really need to do is move that mass over to the right-hand side of that equation, and then we'll be good. So in general, what do state space models look like? They look like a vector x dot, which is composed of our states, is equal to a nonlinear function that depends on uh, x, it depends on u, and it depends on t. So this list of nonlinear functions here represent each equation that we have in the system, like d dot, v dot, etc. Then we're also going to have our output equation, which our outputs y is equal to another nonlinear function describing all our different outputs that we have. So x vector, that's our list of state variables or states. That's like d and v in these systems. So you see that there's no m times this x vector here. It was shifted over to the right-hand side. These are our states. U vector, that's our list of inputs. That's like our force or anything externally acting on our system. And then Y is our list of outputs. Those are things you want to know or you can measure, like car velocity, for example. So this is what our state space model looks like. And then our F, that is our list of functions that describe how the dynamics evolve over time. And G is the list of functions that describe how the inputs and states relate to what you want to measure or what your outputs are, what you want to know. And that is the basics of state space models.